Saxon's Trig, Lesson 59, Advanced Logarithm Problems, and then the color of the White House, which is supposed to kind of give you the feel of, well, yeah, duh, the color of a White House is white. But we'll get to that. Begins on page 387. So advanced log problems deal with a piece you haven't seen before. So let's just start with their first example on page 388. So 3 log base 10 of x equals log base 10 of 16 minus log base 10 of 2. So the first thing I want to look at is, do all of my logs share the same base? Yes, they're all 10, 10, 10, so we're good to go there. So we are going to rearrange the problem. The multiplying 3 becomes the exponent to the x. And then the 16 has a minus sign, which means it's a divide by the 2. And all of the logs cross off because they have the same basis. So all we have to do here is solve. There's nothing new here. This is a review of what you did before. So it simplifies to x cubed equals 8. What number 3 times gives you 8? X is 2. Now, in example 2, they give us log base 7 of x plus 1 plus log base 7 of x minus 5 equals 1. All right, so when I look at my problem and I first check, does everything have the same log base 7? Oh, no, I don't even have a log here. So this is the new part that's causing the problem. But I'm going to start simplifying the first part and then we'll get to that. So the x plus 1 plus means multiply with the x minus 5 and then it equals. So in order for me to make this part work, I need to have this have a log base 7. So what we're implying here is that the 7 gets the given exponent here. So 7 to the first makes it equal to 7, which I can then use here because I've gotten this to a log base 7 by fixing it. Now let's continue. X times x is x squared, negative 5x plus x minus 5 minus 7 equals 0. So x squared minus 4x minus 12 equals 0. And can I factor that, or do I need to jump to quadratic? Let's try a factor. So 12 could go to 6 and 2. 6 and 2 can give me a 4. Let's make sure the signs work. So the one in the middle is negative, so the larger of these numbers must be negative. I need to go from negative 6 to negative 4, so I need to add 2, and negative times positive is negative. Yep, everything checked out. So my two solutions are x are 6 and x is negative 2. Now I said when we did our first lesson about logs that you need to double check that you don't have a negative in there that might throw an answer out. So 6 plus 1 is 7, 6 minus 5, good to go. Negative 2 plus 1, negative 1. Can't have a negative 1 sitting here beside it, so this one gets thrown out and the only answer I can keep is x equals 6. Example 3, 2 log base 3 of x minus log base 3 of x minus 2 equals 2. So the first thing when I check log 3, problem, I know I'm going to have to fix it. So the 2 is multiplying, it becomes the exponent. Minus means it goes underneath, x minus 2 equals, and then the base was 3, so what I'm going to do here to fix it is make that 3 with the exponent of the 2 for the answer. So now we would get x squared over x minus 2 equals 9. This is going to multiply to come out of the denominator, so we have x squared equals 9x minus 18. Got to bring everything together on one side. X squared minus 9x plus 18 equals 0. And can we factor it, or do we need to quadratic? Probably factor. X and x equals 0. 18 can split into 9 and 2, but that's not going to get me 9. 6 and 3 will make 18 and would make a 9. Sign in the middle is negative. Larger number must be negative. How do I go from -6 to -9? Minus 3 more. And negative times negative is positive, so no problem there. X equals 6 and x equals 3. Toss back in. Both are positive, so here with a single x, no problem. 6 minus 2 is good. 3 minus 2 is good. So neither answer gets thrown out. That tells me I have two different answers for those. Now, the color of the White House, obviously that's white. So what they mean in math is what happens when you were given a base of 40, and this is example 4, a base of 42 with a log base 42 with a 5. Well, the 42 as a base and the log base 42 kill each other off. There's your duh. What do you have left? A 5. 5's the answer. Now what happens if they give me an example 5? 9 log base 3 of 5. Now the 9 and the 3 are not identical. However, 9 can be written as 3 squared log 3, 5. So the log 3 and the 3 are going to cancel each other off. The 2 was multiplying there, so it really becomes the exponent, so that makes it 5 squared, and then that simplifies to 25. So again, it's not quite as simple a duh, but it's pretty close. Example 6. I'll flip the page. I was going to say I could probably cram it into margins, but we won't. Example 6. 10 is the base. 4 log base 10 root 3. So the 10 and the log base 10 are going to cancel each other off. The 4 had been multiplying, so it becomes the exponent. So it's root 3 to the 4th power. And so I have to do that 4 times. Root 3 times root 3 is a 3. Root 3 times root 3 is another 3. And 3 times 3 gives me a final answer of 9. Example 7. 3 multiplying, nope, not multiplying. Rewrite that. 3 has an exponent of log 3, 4 plus log 3, 5. So each of the log 3's are going to cancel with the base of 3. And what I had was log statements with the plus sign, which means they're multiplying. So 4 times 5 gives 20. Example 8, log base E. Now usually when we have an E, we think natural log, but I'm going with whatever they give me here, e to the 14th. So the log base E and the base E are going to cancel off, and you are just going to keep the 14 for the answer. And then example 9, log base 5 of 25. And again, this was not written, I have two different ways that I can think to do this. You can change the 25 over to log base 5 of 5 squared, and then the 5, they're canceling off and you're just keeping your 2. You could also have thought of rearranging it and saying 5 to what power equals 25? Well, 5 to the second power is 25. Both feel pretty simple to me, so whichever way you go, you can't take too much time.